Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Maths Methods Exam 2 multiple choice section. So before I get started, guys, if you guys want private tutoring, you can always email me down below. So let's get started with this exam. Perfect. So question 1. F of x is this, the period of this function is what? So it's 2 pi over 2 pi on 3, which is 2 pi times 3 over 2 pi. These cancel out, 3. Choose C. The maximal domain of the function is all reals with the exception of 1. A possible rule for this is, okay, look at the denominator. This is one of the most easiest question because we know that the denominator cannot be equal to 0. And this one, if x minus 1 equals 0, x equals 1, so all reals with the exception of 1. So A is the only one that looks like it would, so A has that domain. This one has all reals with the exception of 5, nope. This one, absolutely not. This is all reals with the exception of -1. And this is absolutely not. So only A would be the best one for that one. Consider the function a to b of f of x1 over x, where a and b are positive real numbers. The range is what? Okay, so if I'm going to draw, I know there'll be y equals 0, x equals 0, and normally it's a hyperbola. Now, what we know is that a and b are positive real numbers. So it means that they can only occur in over here. So let's say this over here is a, and it's in, and over here it's an open circle, and say this is b. And so the range is, so this is what? This is b of 1 on b, and here is a of 1 on a. So your range is open circle 1 over b, 1 over a, close circle. So question 3 looks like D is your answer. The point 3, 2 lies on the graph of the function f. A transformation transforms the graph. Just when you see maps, just say transforms. So a transformation transforms the graph of f to the graph of g, where g of x is this. The same transformation transforms the point A to the point B. The coordinates of point A are what? Okay, so easy. So it's 3, 2. So we can show you a translation to the right by 1 unit. So it means it'll be 4 on 2. And then there is a dilation by a factor of half parallel to the x-axis, parallel to the y-axis. So the y gets multiplied by the half, so it'll be 4 on 1, which means that 4 is C. Consider f of x as x squared plus p over x. There is a stationary point on the graph of f when x equals -2. The value of p is what? Okay, very easy. I'm just going to use my calculator. So I'm just going to say f of x is defined as x squared plus p of x, and what we want to do is find the derivative of f of x and equals 0, and this over here we know when x equals -2 we want to solve this answer for p. So p is -16. Choose A as your answer. Let f and g be two functions such that f of x is 2x and g x plus 2 is this. The function f g of x is what? Okay, so to turn this back to the normal equation, so what's happened is it's been actually transformed, translated 2 units to the left. So what we're going to do is we're going to translate it 2 units to the right to get it back to its original function. So we would say g x minus 2 plus 2. So it'll be 3x minus 2 plus 1. And here will be x, 3x minus 6 plus 1, 3x minus 5. So f g of x is what? So it'll be f g of x, it'll be 2, 3x minus 5, 6x minus 10. Choose D. Question 7. Let f of x be this, where k is an element of all reals. Given that f is this equals 8, find the value. Okay, I'm just going to do this on calculator and say, so I'm going to define f of x. So I'm going to go this. I'm just going to redefine it. So k times log 2 of x. Okay, I'm going to say solve f of y equals x comma y. This is our inverse. And what we're saying is that when y is 8, our x is 1. So we want to solve answer comma k. And we get k is 1/3. So B is your answer. if 1 to 12 g of x is this, and 12 to 5 g of x is that, then what's 1 to 5 g of x? Okay, these questions are always, you know, coming to exams. They've always been there. And yeah, they're the same old, you know, they've been always repeating. So this is not too bad. So this is 1. Let's say this is 1. This is 5. And this is 12. Well, it says here that 1 to 12. So 1 to 12 is 5. Okay. And 12 to 5, or like let's say 5 to 12. So 5 to 12 is 6. Make sure you make that positive when you change these. And then what's 1 to 5? Let's say 1 to 5 is like something like this, and let's say it's x. So adding these two together, x plus 6 must equal to 1 over 12 this. So x must equals 5 minus 6. X is -1. So B is your answer. The tangent to the graph of y equals this has a gradient of 2. The tangent will cross the y-axis at what? Just use your calculator here. So let's redefine this function. So come here. What is log e to x? Okay. So what I'm going to do is I'm going to find the derivative of f of x. And when the derivative is actually equal to 2, we want to solve for x. Alright. Have I done anything wrong here? Yep. So f of x, we've defined it. So the tangent to this has a gradient. Yep. And we've equated it. The gradient, we've done it to that. Perfect. So we got this. So what we can do is just find the tangent. So tangent f of x, comma, this line over here. And we get this. Have I done a mistake here? What have I done? Have I defined this function right? Did I put e here? Ah, he's a constant. No, he's not a constant here. That's what I've made a mistake here. Okay, so if I do this, it's 1 over x. So if we say solve, this answer equals 2, x, we get half. So this half is what we're going to use here. 0.5. So when we sub in 0, -1 is where it'll cross. So C is your answer. Yeah, just make sure to make any basic mistakes via calculator. The functions f has the property this. For all non-real numbers, which of the following is a possible rule? Now, these are always repeating in exams. They're the most easiest and fastest things you can get marks for. So I always do this. So I just define one of them, like 1 minus x, and I try to write the property. So x plus f of x equals f2x. Now here, this is untrue because it would say if it's true. So let's try the next one, which is x minus 1, and bring this over here. False. The next one, which is x. True. So C is your answer. The graph of y equals tan a of x, where a is all real, has a vertical asymptote at x equals 3 pi, and has exactly one x-intercept in the region of 0 to 3 pi. The value of a is what? Okay, I'm just going to do this by calculator. There's things, yeah, just... so, what's tan a times x? Let's write that. And we get this. And we know that there's a vertical asymptote, so what I'm going to do is I'm going to write a relation at x equals 3 pi, which is over here. And so we know that one x-intercept, exactly one x-intercept is supposed to be from 0 to 3 pi. Here, absolutely not, when a is equal to 1. What about 1 over 6? No, because you may think, well, 0 is not an actual answer. So 0 here is, it says it's not including 0. And yeah, so that's not that one. What's 1/3? 1/3, absolutely not. Remember, 3 pi to 0, they are not inclusive. And there's an asymptote, so nope. What about 1 over 2? Aha, 1 over 2 is good because, yes, we do get one solution. It crosses over here. Yeah, so the one that has it when a is 0.5, so C. The discrete random variable x has the following probability distribution. Let this be the mean of x. Then what's this? Okay, very easy. Just going to go on my calculator and I'm just going to find the mean. So the mean is what? It's 1 times 9 over 20 plus 2 over 10 plus 3 on 20 plus 18 on 20. Okay, so this over here is your mean. So let's control enter. So what we're saying is, what is the probability that x is less than, let's say this is 2 to be exact, less than 2? Well, it's these two together, so it's just 1 over 4 plus 9 over 20. So what's 1 over 4 plus this? It's 7 over 10. So E is your answer. In a particular scoring game, there are 2 boxes of marbles, and a player must randomly select 1 marble from each box. The first box contains 4 white marbles and 2 red marbles. The second box contains 2 white marbles and 3 red marbles. Each white marble scores -2 points, and each red marble scores 3 points. The points obtained from the 2 marbles are randomly selected by a player and are added together to obtain a final score. What is the probability that the final score will equal to this? Okay, so let's just draw a tree diagram here. So let's say in the first actual, like the first time he picks, so from the box, you know how there's 2 boxes? So in the first box, let's say he picks so white, red marbles, and then he ticks again, so white, red marbles here. And in the first time he picks, we know that there are 2 boxes of marbles, so that must be blah, blah, blah. So the first box contains 4 white marbles and 2 red marbles. So in total, that's 6. So 4 on 6 here, and this is 2 on 6. The second box contains 2 white marbles and 3 red marbles. So in total, it's 5. So it contains 2, so 2 over 5. And this is 3 on 5. So this one's 2 on 5. And this is 3 on 5. And each white marble scores -2 points and each scores 3. What is the probability that the final score will equal 1? Well, we know, yeah, so if white is added, it'll be -4. If red and white is added, it'll be +1, yes. If red and white, okay, this one's +2. Red, 6, it'll be +6. So if we want the final score to be equal to this, it's just these plus these. So let's write those in our calculator. Four over 6 times 3 over 6, so 3 over 5 plus 2 over 6 times 2 over 5. That's 8 over 15. Choose E. So I'm very confused with this question because I'm not too sure actually. Is that? Look, I will double check the answer. Yeah. So 2 events A and B are independent. So straight away when I see that word, I'm just going to say probability of A intersection probability of B must equal probability of A intersection B. Always write it. When you just see independent, make sure you write this. Where probability of B is this and probability of A union B is that, then probability of A is what? Okay. Okay. So I think what I'm going to do is I'm going to first say, what am I going to do actually? Wait. If I put, we know probability B is equal to 2 times the probability of A, so it'll be probability of A times 2 times probability of A equals probability of A intersection B, which is 2 probability of A squared. Okay, A intersection B. And we know by the addition rule, actually, that the probability of A plus the probability of B, which is just 2 probability of A, must minus this over here, 0.52, must equal to your probability of A intersection B, which we've already calculated, which is 2 probability of A squared. Okay, this is an actual, let's say X is probability of A, so it'll be 3X minus 0.52, 2x squared. So I'm just going to solve it in my calculator. Solve 3x minus 0.52 equals 2x squared, from x. So it cannot be this one because this is greater than 1. Probability is less than 1. So it's this one. So 1 over 5, which is, to be exact, 0.2. So choose B. The probability density function is given by this. The median f of the function satisfies what? Okay, so we know the median is from 0 to some value, that's am here, of 1 over 12, 8x minus x3 dx. Let's do on our calculator. So we're saying 0 to m, and it pretty much equals to half. That's what the median does. So 1 over 12, 8x minus x to the power 3 dx, and that all equals to 0.5. And let's multiply both sides. So let's multiply this answer by 48 to get rid of this 48 here. And we get this. Let's write this down. Negative m squared minus 16, 24. So negative m4 plus 16 m squared is 24. It cannot be these because we don't have 24 in them. If I move them all to the other side, E looks right. Generally approximate the area between the x-axis, the graph of this, over the interval from 0 to pi over 2 using the three rectangles as shown. Jamie's approximation is Jamie's approximation as a fraction of the exact area is what? So like the rectangle area over the exact area, that's what they're telling us, yeah. So the fraction. Okay, that's not too bad. So I'm going to go on my calculator. I'm going to define f of x. Well, f of x is what? 2 plus 2x plus 3. And then what I'm going to do is, I know the width of them is pi over 6. Pi over 6. And I know that the first one is f pi on 6 plus f pi on 3 plus f pi on 2. Aha, this is our area of the rectangles, all of the rectangles. And what about the area of the actual thing? Well, it's just the integral from 0 to pi over 2 of f of x dx, perfect, which is this. And we're saying this divided by this, it's 7 over 9. So choose B as your answer. The turning point of the parabola y equals x squared minus 2bx plus is closest to the origin when... I'm just going to do this by calculator. I'm too lazy actually to even... Let's just do this by calculator. So if I'm saying x squared minus 2b times x plus 1. Okay, let's make a slider. So, okay, let me just control M this actually. Just make the whole new page. So let's rewrite it again. Times b times x plus 1. Okay, this, so let's say it's saying let's choose the first point, which is 0. It says b equals 0. So, okay, the distance is 1. What about negative 1? Okay, nah, same distance, no change. And also, yeah, what about negative 1 over root 2? Let's try one of those. Negative 1 over root 2. It's much closer. What about half? The way we would... let me just zoom it in so I can actually see like how close it's getting. Because I'm not... Actions point. Okay, move this out. Okay, let's just double check everything. So we said negative 1 over root 2. Let's double check it. Is over here. Okay. The next one is negative 0.5. Aha, no, it gets further away. So what about a quarter? 0.25. No, it's further away. So the most closest one's actually C. Yeah, when it's 1 over root 2. Let's try even 1 over root 2. Yeah, this they are pretty much the most closest in terms of all of them. So choose C. Question 18. Consider the function this, f of x x to the power of pq, and g of x is this, where p, q, m are all positive integers, and p, o, q, m, n are fractions in the simplest form. If f of x is greater than g of x is equal to 0 to 1, and that g of x is greater than f of x from 1 to infinity, which of the following must be false? I'm going to do this by calculator. There is no way I'm touching this by hand. So let's say x to the power of p over q. Let's draw that. Let's put some sliders and put them over here. The next sliders, x to the power of over m over n. Okay, we have these. And let's just move these away. Okay, and let's kind of... So the first condition says q is greater than n. Let's say q is greater than n. Let's try to make that happen. So we're saying q, let's put q as 2, and n is 1. Yep, so q is greater than, and p must equal, p in m are equal. Yep, that's perfect. So let me just enter. What do we see? So, and it says, is this condition met? F of x is greater than g of x. So is the blue graph greater than g of x from 0 to 1? Yes, that's true. And is g of x greater than f of x for 1 to infinity? Absolutely. When 1 to infinity, it is greater. So A is right, so it's not false. What about the next one? M is greater than P. So let's put this as 2 and P 1. And it says that Q and N must equal. So let's just put these as 1. Q and N. Okay. Same condition. Absolutely. The blue graph is greater for 0 to 1. And the actual red graph is greater from 1 to infinity. So it still met the condition. The next one is Pn is less than Qm. So let's look at this. Okay. If we're saying Pn, let's say, because we want Pn to be less, let's say it's just, so P is 1. So P is 1, N is 1, Q is 2, and M is 2. So because 1 times 1 is 1 is less than 2 times 2 is 4. Yeah, 1 is less than 4. So that works perfectly. So we can say that P is 1, N is 1, Q is 2, and M is 2. So let's do that. Is the condition still being met? Absolutely. The blue graph is from 0 to 1 is greater. And from 1 to infinity, the red graph is greater. Yeah. What about D? It says that when f dash of c, so this graph over here, the blue graph, a point from 0 to 1. So let me just zoom in. Okay, so let's look at this. So it's saying a point from 0 to 1, which is c. Let's say c is here on the blue graph, and the gradient is, let's say the gradient's nice over here. Okay, so the gradient, let's say it's like a nice positive over here. It's the same as the gradient. So C, let's say C was here. It's the same as this gradient. Yeah, they do look the same. This gradient at the same point. Let's just check the last one, actually, E. So it says that from D is 1 to infinity, so it's around this. It says that the gradient of the blue graph, let's say at this point, which is like this, is the same as D on this. Absolutely not. This one's much steeper, so E is false. The graph of f of x, this, and g of x is this, is shown on the diagram. The integral expression that gives the total area of the shaded region is what? Okay, let's look at the first one. 0 to 3, absolutely not. B says 5 to 3, no, that's not complete. Next one. 0 to 3. Okay, so it's 0 to 1/3. Cos x, yes, the upper function's cos x minus sine x. Okay, so we got this area right over here. Perfect. Then the next one, it says -2. So from 1/3 to 1, cos x minus sine x. But whereas sine x is up, okay, but at least he's put a negative. So that gives this area, and he's multiplied it by 2 to give this area because of symmetry. Then the next one he's saying is 5/3 to 3 with upper function sine, but he's put a negative, so that's all right. Yeah, C looks very good, actually. The other ones, let's just have a look at those. So to 1 to 5/3, 1 to 5/3, the upper function's cos, yep, minus sine, yep, twice, we'll give you that. Then the next one's 5/3 to 3, so 5/3 to 3. No. Okay, 5/3 equals 3, this. But why does he put a 2 here? That's wrong. And the other one, oh hell no, I'm not gonna look at that one. Wait, just let's have a look. I think here, he's just made a mistake by putting, he's done this right actually, 2, so 1/3 to 1. Okay, and the upper function sine, okay, that's good. And it's multiplied by 2, perfect. And he's saying that 5/3 to this, but it's sine. This is supposed to be sine over here, minus thing, yeah. So C is the right answer. Last question, perfect. 20, the differentiable function is a probability density function. It is known that the median of the probability density function is at x equals 0. And f dash of 0, so the gradient is 4. The transformation T transforms the graph of f to the graph of g, where now g is the probability density function with the median at x equals 0. So it's still the same place, but now g dash of 0 is -1. I'm just going to draw a graph to really look at this. Okay. And so at 0, let's say it's some graph that looks like this. Originally, it looks like this. I don't know, something like that. So at this point, the gradient is 4. And it's good. Okay. Perfect. And what's happened is it's still the same point, but it's now become negative. So the gradient has changed. And it's become less steeper. So it would have been looking like, now it would look like, so it'd be negative, but like, it would look like this. Something like this. Perfect example. Something like this. So let's just have a look at these transformations that would transform this to that. Wow, I cannot be bothered. Okay. Well, okay. Let's have a look. Here, let's look at A. What they've done is they've reflected it along the y-axis. So if we reflect this along the y-axis, so imagine this whole thing, something like that. Okay, the gradient will change. Now it will become negative, and there's also a 2 on it, so it's multiplied by, well, it's a dilation by a factor of 2, so it'll be multiplied by a half. So you know how the gradient here is 4, it'll be -2 if it's going through this point here. Okay. Looks alright, so it's done something. But okay, let's look at this one here. So here is a reflection. So if we even reflected it, so let's see if we reflect. No, absolutely not. Even if we reflected it, yes, we may get a negative gradient, but it's a probability density function, so absolutely not. Anything that has a negative on this is wrong. Okay. And yeah, also C is wrong because you need to make sure it gets reflected, so it has to have a negative. And this one's just all positive, absolutely not. So it's one of A or D. Okay, how would I do this? Wow. Because, yeah, I'm not too sure how. So I'm just going to be honest. Because I know it could be only A or D, I'm just going to expand them. So x dash, -2x, y dash, half y. And so x is what? -x dash on 2. Y is equal to 2y dash. Knowing this, why don't I just go on my calculator and just say, okay, let's say we had a graph that looks similar to what we draw. So let's say it was like negative x squared. So negative x squared, let's put a negative, plus 4. Something like this. But at 0, it's pretty much 0, the gradient's 0. So what we want to do is let's tilt it. Let's maybe add a sign into it. Sin x, something like that. Okay, now it's a little bit tilted. So let's say this gradient over here. Let's kind of zoom in. All right, because this is going to help. Like, this is just a faster way without even knowing the concept. You can just do this. So, okay, so this gradient over here is nice. So it's a positive, perfect, at x equals 0. Done. Now, if we apply these transformations, for example, let's take this f. Oh, let's actually here. So f3 of x is this. If we applied those transformations as we did, so we said that we wanted 2y equals this function, but putting so negative x over 2. Also here will be negative x over 2. And we want to solve answer comma y, and let's see what happens. We've just applied the transformations of a. Okay, what can we see? Okay, so the gradient has become negative and it's become less steeper, which could be true. So a looks very promising actually, because we know, all right, this is good. We'll keep that in mind. What about d? Let's just do d first, then now d. So x dash negative half x, y dash 2y. So it'll be negative 2x dash equals x, y dash over 2 over y. So let's now try the next one. Let's bring this, and so it's equal to y over 2 negative 2x negative 2x. Enter. We solve. Answer y. Take this over here, and let's paste it. Enter. Okay, no way. That's actually that's rubbish right here. Well, it has become a negative. We can see it's become a negative, but it's become much steeper. Yeah, so only a could be right. And yeah, I mean, this way, this was just a guess and check right now, because I only eliminated 3 of them, and yeah, a looks right. I gotta double check all the answers actually, because I'm not too sure. This was just, I tried this exam for the first time, so I'm not too sure. I may have got one wrong or 2, but yeah, I'm just gonna double check the answers after this. So yeah, I hope these are all right, but I hope you guys enjoyed this video and learned something. So, sometimes for the multiple choice, you don't have to give yourself working out and this. Just, what you can do? Just use your CAS and put some values in, and, because, I mean, they do give you the values, luckily. They give you 5 options, and these values you can shove in your calculator, and you can just see which one looks the most right. Yeah, so sometimes using your calculator to your advantage is the best thing you can do. You can save yourself so much time, and that's the point of using your CAS for multiple choice. The main point is smash through these multiple choice questions as fast as you can, because the ones that are the most difficult is the extended response, and that's where you actually need to put time in understanding and the concepts. So yeah, that's why I always use my CAS to pretty much finish these quickly. And yeah, I hope you guys learned something, and yeah, I hope you guys take care of yourself and take care of yourselves. Bye bye.